This is Lab 4 Oscillations. I will first go over the physics principles behind this lab, then I will summarize the procedure, then I will go over my code, and then I will discuss and analyze the results. For the physics principles behind this lab, we will be using Newton's second law. We will be using kinetic energy, which is equal to 1/2 mv squared. We will be using gravitational potential energy, which is equal to mgh. We will also be using spring potential energy with the equation shown. We will also be utilizing energy graphs, which graph all three of these energies at particular times. And we will also be using the energy principle, which basically is the conservation of energy, saying that energy cannot be created or destroyed. For the procedure for this lab, we are given a video of a mass attached to a spring oscillating back and forth. We have to track the X and Y components using tracker. And then from this data, we can calculate the spring constant and the relaxed length using the equation given. And then from that, we can find the initial conditions to plug into our model that will model the oscillation using kinetic energy, spring potential, and gravitational potential. And then we need to compare and analyze the observed data and the model data. Here is the video in tracker. In the top right is the position versus time graphs for the X component and the Y component, and in the bottom right is all the data from those graphs. Here's my code. At the top is the display for the model. Further down I have the initial conditions, the ball mass, and the initial position from the video. I also have the time step, I have gravity, and I have the calculated spring constant and the calculated relaxed length. Down here are the equations for the different types of energy. First is the kinetic energy, then the gravitational potential energy, then the spring potential energy. And down here is the total energy of the system, which is all of these added up together. Further down I have my while loop, where the time is set. I have the initial energies, then I have my gravitational force, my spring force, and the net force. I then have my velocity update formula and my position update formula. And then down here I have the same energy formulas, and I also have formulas for the change in energy for each different one. Here's my code running. Here we have the energy versus time graph. The blue line is the kinetic energy, the red line is the gravitational potential energy, and the green line is the spring potential energy. The orange line is the total energy of the system, and as you can see, it remains 0 for this entire time, and this means that the energy principle is satisfied. Further down I have the position versus time graph for the Y component. The red line is the actual position versus time, and the blue is the model. Down here we have the X component with the same graph, and as you can see, this one is a little further off than the Y component. Here is the model run when I use the X component for the period and calculate a different spring constant. Previously I had used the Y component for the period to calculate the spring constant. As you can see, the Y component is much further off and the X component is a little closer. Overall, I think using the Y component to calculate the period and then the spring constant produces better results. This concludes my lab.